But is it? Or is it about...
rate, isn't that change?
Or is it about... Well, that's fair. Okay. So we're adding to our notes. Here is our next example problem. You ready? A particle's velocity is given by v of t equals t cubed minus 2t squared plus 4. Where t is in minutes, v of t is meters per minute, and s of t is the particle's position. So velocity is v of t equals t to the third minus 2t squared plus 4. T is minutes. V of t is meters per minute. S of t is the position of the particle, like normal.
What is S stand for position again?
I'm not sure. Position. All right, find the net change in the distance over the first 5 minutes. And when they say net change, we are going to think displacement. Okay, so how do I write this?
0 to 5.
So the integral from 0 to 5, v of t dt, okay? And just a little hint that is kind of helpful. When you do an FRQ, if you write this, you get full points, okay? If you write it as 0 to 5, t to the third minus t squared plus 4 dt, I have a typo on purpose. If you write this, you get no points. Do you see the difference? Because I missed the 2. It was an accident, but I missed the 2. Therefore, I'm wrong. Do you see that? So if you're doing an FRQ and it's calculator active and you're about to plug it in your calculator anyway, don't write it like this, because then if you miss something, you actually get marked down. This is a little bit easier to be accurate with. They're both equally accurate as long as I have the 2 in there. Does that make sense? Okay. For the sake of time on this assignment, I'm going to say go ahead and plug these into your calculator, but every so often do one by hand, just to make sure that you can do it by hand. We don't want to, the first time I taught this unit, I let them do everything by hand all the time, and then when it got to the test, and the test was majority calculator inactive, they couldn't do them by hand anymore. So we don't want to completely depend on our calculators. We want to practice doing it by hand every so often, but I know that we can do this by hand, right? Okay, so I would say if you run into one where you're like, ooh, that's terrible by hand, maybe do that one by hand. And then the ones like this where they wouldn't be bad by hand, just go ahead and do it in the calculator. Make sense? Okay, so if you're looking at it and it's like there's a radical in there or there's a trig function in there or something like that, those are the ones that should be done by hand, because those are the ones that are going to trip you up. Something like this, probably not going to trip you up unless you make a mistake somewhere. All right, so how do I type this in the calculator? Math 9 from 0 to 5, and these are in terms of t, but it doesn't matter. Your calculator will treat the variable the same way, although if you want to do the variable t, you can. Without doing mode, you can just use the alpha button. So you could do these in terms of a if you wanted, a cubed minus 2a squared plus 4, and then have dA. It would do the same thing. Okay.
Set your science or anything.
Yeah, you can do that too. So what do we get from this? 917. All right, and if I want to figure out what my units are, I just have to go back and remember that this is the area of a rectangle. So this represents the height of the rectangle. That's the V of t. And what are the units for V of t?
Meters.
Not meters.
Oh, for V of t, meters per second.
Meters per minute. And then d of t, the width. What would the width be? Look back at the problem. Minutes. It's a change. It was the change in the t value, which was minutes. So if we do meters per minute multiplied by minutes, then what are the units total?
Meters per minute squared.
Meters.
Oh, right.
Because the minutes cancel, right?
Big brain.
So the displacement, the distance between the beginning point and the ending point is 92.917 meters. Okay. Part B. If we are going to find the total distance traveled in the first 5 minutes, then we're still going to say the integral from 0 to 5 of v of t dt. But we have to think back to the way that we worked with these problems when we first started and we did rectilinear motion. Okay. So if you guys remember when we did displacement in the very beginning and we did it by hand and we weren't using integrals, we just figured out the location at the very start and we figured out the location at the very end and we subtracted those numbers, right? And if we had done this by hand, we would have done the same thing. Right, we would have had the position equation, we would have plugged in 0, we would have plugged in 5, and then we would have subtracted those to get this. If we think about how we found total distance, we had to figure out the moments where it changed directions, right? So we had to say, oh, it's negative, and then it's positive, and then it's negative, and then it's positive, and we had to find the distances between each of those numbers, and we had to add them up. Does that make sense? So we're going to put an absolute value around the v of t because that's going to help us keep track of when it switches directions. Does that make sense? Okay, so we're going to type this in again, but we're going to do absolute value this time. So math 9, 0 to 5. Math over to number, absolute value. X to the third minus 2x squared plus 4. Okay, and what do you guys get?
92.917.
Okay, so if the total distance and the displacement are the exact same number, what does that tell you? Never changed directions, you just went one direction the whole time. Okay, so we're going to say 92.917 meters again.
Why don't we do things like 9166 for the lack of it?
I'd say like I think probably because, well, I'd have to look back at the elementary standards. I want to say you guys learned how to work with decimals before fractions. It might be because at this level, like when you were in upper level math, at this point you would be comfortable writing that as a fraction, and so we'd prefer that instead. Because the reason you put the number with like the repeating, the line over the top, is for accuracy, right? You're saying this repeats forever, so it's a level of accuracy that wouldn't be there if you didn't put it. But we wouldn't do that because we just write it as a fraction instead. So my guess, I'd have to look back at the elementary standards to see like why they teach that, but that would be my guess, is that back in the day they teach you that because you're not as, you can't handle it as well, but at this point it's like, oh, if you want to put the repeating decimal, just go ahead and write the fraction.
It's 1,115 twelfths.
Yeah, it's a wonderful fraction, I always say. All right, part C. If S of 0 equals 5, what is S of 3? And I would say you should probably star this, highlight it, do something, because this is a very common problem, and it is one that really messes with students, okay? All right, so if we wanted to know s of 3, we would say the integral from 0 to 3. That's how we're going to find s of 3. So we're going to say s of 3 v of t dt. And if we think about what we are literally finding when we do this, what are we actually finding when we do this?
The difference between S of 3.
Yeah, we're finding s of 3 minus s of 0, right? So if we only do this, are we actually getting the answer?
Yeah.
No, we are not. We're getting s of 3 minus s of 0. So what should we put in the front to make it so that this final answer would just be s of 3 and not s of 3 minus s of 0?
S of 0.
We should put s of 0 in the front. So if you do s of 0 plus the integral from 0 to 3, then you get s of 0 plus s of 3 minus s of 0.
You get S of 3.
And these cancel out, and you just get s of 3. So this is kind of like a roundabout way of getting back to s of 3 without having the function s of t. Does that make sense? Now, in this problem, we do have the equation, right, for s or for v of t at least. We can plug it in. We could have found s of t if we wanted. However, this is a nice thing to use when you're given a function that you don't know how to integrate, or if you're given a picture where you can calculate the area, but you don't have a function you can plug in. Does that make sense? So mathematically speaking, we're going to pretend that we could not have done this problem by hand. Then this is a really handy way to do it. To say it's kind of like your initial value, like a y-intercept almost. It's saying like I start off with this base number and then I see how much it grew from there. Does that make sense? And then I can see exactly what that value is of the position. All right, so we're going to go ahead and calculate that. We're going to say s of 0 is 5. So we're going to say 5 plus the integral from 0 to 3 of v of t dt. And let's see what that gives us. Not very much typing.
Quiet typing.
I know.
You're so savant.
You hear typing now.
Got
19.25. Okay.
Oh, I see what I did wrong.
Okay.
I added an X somewhere.
My plus omitted itself, so I was doing x cubed times 2x squared. I got a very large number.
Yeah. So how would we write this in the context of the problem? We just did all this math.
That at t equals 3, the position is 19.25.
Mm-hmm. Yep. So we would say at time t equals 3 minutes. We wouldn't say it has traveled because we're going back in time, right? We're saying exactly, think about what we just evaluated. We found s of 3. Now, Tristan, if I cover up this 5 and see what we got for that, it would have been 5 less, it would have been 14.25. So if I cover up this 5 and get that 14.25, then we could say from 0 to 3 it traveled that far. But as soon as we have that 5 in the front and we know that this was us evaluating just s of 3, then we say at that exact moment in time, it was 19.25. That was the position. Does that make sense? Mm-hmm. And that's specifically because of the 5 we had in the front. And that's because of this math right here, right? That the integral itself gave us s of 3 minus s of 0. And so when I put that 5 in the front, I was canceling out that. So I no longer have a displacement as a result. Now I have just a plain position. Does that make sense? Okay. So we're going to do that part again because I know that part is kind of funky. So we're going to say f prime of x is 3x squared minus 8x plus 9. And f of 5 is negative 16. And we are going to find f of 10. So the slowpoke way to do this problem, the slowpoke way, would be to take the antiderivative and put the plus c in the problem and plug in 5 and set it equal to negative 16 and solve for c and then go back and plug in a 10. That's the slowpoke way to do this problem. But we have calculators today. So today we're going to do this the fast way with our calculators. So what do I have to think about to plug this into my calculator?
Think about the integral, which would be from 5 to 10. So
Okay.
The integral 5 to 10, f prime of x dx, and then...
And when we plug this in, I'm going to stop Elena because I want the rest of you to think about it and see if you can figure it out the same way she did. If we were to do this, our result would do what?
Find us the interval between 5 and 10.
It would give us f of 10 minus f of 5, right? That's what that would give us. Okay, so if we want our end result to be f of 10,
Subtract 16.
we have to put f of 5 in the front. So it's not just that you can start with the initial value and do it. You can really start with any value and do it. Does that make sense? Okay, so then the f of 5s cancel out, and then we just get f of 10. So if we want to figure out what f of 10 is, and we don't want to do it the long way where we are number crunching by hand and having a plus c and solving for c and then plugging a number in, we can do it the quick way by doing this. Does that make sense? Okay, so let's go ahead and plug it in, see what we get. It is really handy, and I think it messes with students for a little while until it starts to click. And then it's like, ooh, what a nice tool I have here. In fact, it's almost nicer to do it this way than it is to find C, even if you're doing it by hand. All right. And what did you guys get?
604.
604. Look how simple that was. Okay. Make sense? Okay. So the plan for today is mostly in a calculator until you find one that makes you a little uncomfortable. And if you find one that makes you uncomfortable, you should practice it by hand. Okay? Because that discomfort is telling you that you're not sure about it. And so that's one that we should definitely make sure we're good on. Sound good? Okay.
Can it be discomfort just because we think they're ugly?